will have a good spend a good time here listening to my presentation and speaking about clean code, right? So the topic of my presentation is how to write clean code on TypeScript and JavaScript code, and also we will touch a bit discussion about Uncle Bob and Kai's Muratori contribution to clean code principles and comparing clean code and performant code. So agenda will be the next. We have a brief introduction. Then the next we will talk about importance of writing clean code. We will talk about clean code principles on TypeScript and JavaScript. Then we will take a look on Uncle Bob and Kai's Muratori contribution to clean code, and in case we have enough time, we will take a look on the real examples of performant and clean code. Right. Let's start about just reminding everyone about basic reason and importance and why we care about clean code. The clean code is easy to read and understand, which is essentially essential for collaboration and future maintenance. And when code is readable, developer can quickly grasp its purpose and logic. And we see on the first example that it's much easier to work with a function which is named descriptively, like a double number, and we understand what function supposed to do, right, rather than working with just a random naming function, right? Also, clean code is easier to maintain and extend, and when code is well organized and follows consistent conventions, it reduces the risk of introducing unexpected bugs when new changes come. In the good example, we could see that the code is broken in a smaller part and meaningful part. We set the new variable, although it's more descriptive what was happening and what was the intent of the code. Also, clean code is good for debugging and testing. It's easier to debug when functions are small and have a single responsibility. It is easier to write unit tests for every function and make sure that every part of the application is working correctly. So in good example, we have code which is divided on a smaller function, and each function has a single responsibility, which is one of the most important principles of clean code. And this makes it easier to write tests for each functions and debug issues, if any. Also, clean code is more scalable. As project grows, clean code helps to ensure the new features can be added without causing chaos. And if we have a good modular base of the code, our team of developers could work independently. They could jump into the project faster. And we can see in a good example, user service class encapsulate the user-related operation, making it easier to manage and extend an application as the application grows. And also, clean code facilitates collaboration when multiple developers work on the same code base. Following clean code principles ensures that everyone can understand and contribute effectively. In the good example, the function named square and the JavaScript docs comment provide clear information about the function's purpose and usage, making it easier for other developers to understand and use. So to summarize this part, writing clean code is essential for creating a maintainable, scalable, collaborative software. And by following clean code principles, developers can ensure that their code is readable, maintainable, and easy to debug and test, and which is essential for quality of our software. And the next part of presentation will be discussing specific for JavaScript and TypeScript clean code approaches. There may be much more items that could be included in such in accepting code as a clean, right? And factors which could be taken into account here. Now, also we'll spend a little time only on few of them. So in JavaScript, it's important to know that we use const and let and not var, right? Because they are block scoped and provide better intent, like const for values that shouldn't change, and let for those that will. And we are using arrow functions because they maintain the lexical scope, and like it's ideal for callbacks and maintaining of the reusing the code in future. We also should use template literals for string interpolation, and they are cleaner, support multiple strings, and reduce the chance of errors in string concatenation. And we should use destruction for easier data access, and which makes code more readable. Right? Also, we should use default parameters, which makes functions usage clearer. And we should use async await for asynchronous code. We could wrap it with a try and catch, and it's much clearer. Clearer code. It's much easier to debug, right? And we should avoid global variables, because they could be accidentally overwritten and influence on all the application. And encapsulation inside a function protects us from it. And we should prefer immutability, like using not mutable approaches for copying and array spreading. Okay, and also about TypeScript, which is basically by its sense improves the JavaScript quality of the code, because we are start on using annotation where we set the specific type for the entity, and if we follow it, we specifically know what is expected in the function, and can easily on the development in the stage of development we can easily catch potential errors, bugs, and improve the code in process in developing process. We also good suggestion is to prefer interfaces over types, because if we use interfaces which define the shape of object, it's easier. Interfaces are better in readability, and they are more extendable. That could be reused in other part of the code, and could be extendable by creating new interfaces using the existing one. Also, we use enums for fixed sets and constants. Enums, they group our values and related constant, and later we could reuse them in application and know the specific place of our constants. And we should leverage generic for reusable components, reusable and types of components. Like we are not using any, we are using generic. We should use optional chaining and checking on null and undefined values, right? And we should avoid using any type value. Yeah. So that was about JavaScript and script, just the basic reminding of how to take care of your code when we write application on JavaScript and TypeScript. And the second part of presentation, it will be just another point of view on a clean code. Because what we are talking about is just basic sets, right? Basic rules, which we consider as right, right? We've been talked that we have to follow clean code principles, right? Our code should be clear. But there is another point of view that not always clean code could be the best approach, right? Not always we should care about it till the end and argue like about naming of functions and so on. And let's come to that topic and discuss it a bit, right? When the whole concept of writing clean code, it's probably started when development begins and team collaboration begins. Although like it was well structured and documented and presented and booked, right? Written inside a book by Uncle Bob, whose real name is Robert Martin. And he is well-known software engineer and an author and speaker and in software development. And he is a strong advocate of clean code principles. He emphasizes on readability, simplicity, maintainability of software design, right? And his main principles, they cover what we just talked. He says that that in clean code it's important. Meaningful names are important, and they should reveal the intent. We talked about that. Functions should have a descriptive name, right? Variables, functions, classes, they all should describe what they're doing. Also, Bob Martin mentions that functions should do one thing, which is basically single responsibility principles. We define the functions, and it does one thing, and we could test it, and we could debug it easily. We know what it is doing. Also, he's saying about avoiding side effects. We also said about that in JavaScript, that we are not setting global variables. We are not copying array as array, right? And object as object, right? So we're avoiding such side effects and using like spreading, for example, in JavaScript for that and so on. And the code should be readable. That principles means that our code should be written in the way so that when we read it, we feel that we are reading the book. We don't have to think a lot. We just read and understand what's happening, right? And also, he mentioned about comments that they should not describe what's happening inside the code. They should describe like why that code, like more about why that logic choose. It may be something like to do, what's supposed to do, what's next, like something useful, not just explanation of the code, right? Yeah, and here we have on the right side of this presentation, we have examples about a good comment and bad comment according to Bob Martin's principles, right? And also that we are like example with global variables, that we are not immuted. It's not adding a side effect here, right? In a good example. And so Uncle Bob, he leans toward clarity, abstraction, and consistency, and especially what important here to mention also the abstraction part, right? So we said that functions should do one thing, and we set a lot of functions, and we add abstractions layers, right? We use object-oriented principles and so on and so on. But let's take a look on another approach about clean code. It's about case Muratori approach. He is software developers specializing in game engine research and development. And he advocates for deep understanding of software fundamentals, emphasizing performance optimization. And his approach often involves building systems from the ground up without relying heavily on external libraries, aiming to teach programmers a core principles of software development. Case Muratori has critiqued some of principles of clean code and emphasizing practicality, performance, and real-world applicability. That discussion with Case Muratori, it started with the article when Case Muratori just copied one of part of the code from Bob Martin book and tried to improve it. While he was like just making a small rewriting, just removing some encapsulation and some abstractions, he improved the speed of the code on 20 times, right? And that was that bring him to idea that maybe the whole clean code approach, which we like were pushed to follow, where we thought that it's right. He mentioned that maybe the whole generation was taught not in the right way, right? And that brought us to the situation when small application, which was easily working on some not performant computer 20 years ago, now it requires much more performance, much more cores, and bigger computer. And they also have, like Bob Martin and Case Muratori, they have like a few discussion together. They discussed their points together. The discussion is documented, and everyone could find something to agree and something to disagree here. But let's take a look on case Muratori points here. And he is talking about practicality over idealism. Focus on practical solutions that work well in real-world scenarios, rather than strictly follow idealistic principles. In the top example here in the code, we could see that calculate total, the first idealistic example, is pretty clear. Like it's just using reduce and a pretty clear, very beautiful code and so on. Although for some developers, it's much easier maybe to understand just a basic for cycle. And it's like especially for developers who just come from another language, they just could work with the for cycle, and that's okay. And we should not push to some functional approach just because it's cleaner or so on. It should the code should be practical. And also, case Muratori emphasize performance consideration and consider the performance implication of your code, especially in performance critical section. Is a more performant example on the right, on the bottom of the right of the slide. A loop is used to find the maximum value, which avoids the overhead of spreading the array on max function. In some real world scenario, when we are talking about a small amount of numbers, it's okay just to use max, and it's easier and clear and so on. But when we are talking, when we imagine a huge amount of data, it may influence on performance, and we should remember about such drawbacks of a clean code and using like encapsulated functional approaches. Also, case Muratori says that we should avoid over engineering and make and keep the code simple. And here he compares the class, user class that was set to get name and get age, while it may be just enough to have like object with which implements like interface, right? Okay. And he also emphasized on balancing readability and performance. We should aim to balance readability and performance, making trade-offs where it's necessary. For example, in balanced code, a loop is used to filter even numbers, which can be more performant in some cases while still be readable, right? We could have used filter. It's also clear and understandable for most developers, but on some cases, writing just raw loop might be faster. So case Muratori, he's emphasized on pragmatic engineering, on performance and real world trade-off, which means that if my code not perform like very slow but clear, it does not make it the good code. Rather, it should be performant enough and clean enough to make to have that balanced application, balanced code that could minimize using of resources and also be clear for other team members to understand the code. Okay, and here's like comparing table of approaches, and the first one is readability. The first factor which we would like to discuss is readability. when Uncle Bob strongly emphasized on readability and that code should be clear, consistent, and readable, the Kant's Muratori here he says that readability is not the main goal. The main goal is performance of your code. So you have to be clear, be honest, right? Be honest that you're not writing code for the code. You're writing it for doing its work. And also, one more factor is single responsibility principles. While Uncle Bob emphasizes that functions and classes should have a single responsibility, Case Muratori agrees, although here, like he emphasized on not following that principle, like strict following that principle, rather to think about if it's real, if functions and classes really should be splitted, and sometimes like splitting could influence also influence on amount of not needed code and could increase even make readability worse because you have to understand to compose together a few functions while you could use only one for that specific solution you needed. Also avoid over-engineering. Uncle Bob, he says about simplicity and avoiding unnecessary complexity. And Case Muratori, he criticized over-engineering and promoting practical and straightforward solution. He says about that if you need like solution right now and you need it fast, there is no point to spend your time on making it perfect, right? Also, one more factor is don't repeat yourself. Uncle Bob, he says about that duplication leads to maintenance issues consistency, that like variables and functions that should be set only once. While Case Muratori has his supports don't repeat yourself principles, although he doesn't think that it's very harmful. I'm sorry, he thinks that it's harmful, although he does not want it to be considered as the way, like to make all the code abstract, to write all over abstract code. When you to follow the don't repeat yourself principles and make it like huge. Like you're writing code following the principle don't repeat yourself, but you're writing a lot of abstraction functions for that to follow all the solid principles also, right? And it make huge while you just could have like two types of repeating like configuration code and just do your work. Also, Uncle Bob, he says about prefer polymorphism over the if-else statement. It's also about like abstraction. Like he encourages the polymorphism over branching to avoid code and growth in complexity over time. Like according to Uncle Bob, we should set new classes which inherit classes if we need some extension, right, to our code, to our entities. While Case Muratori, he's skeptical about it. He prefers a straightforward control flow when it's easier to understand and debug and more performant. And the last one is performance consideration. Uncle Bob, he says about that clean code should not sacrifice performance unnecessary, although on Uncle Bob books and presentations, he never paid a lot of attention on real performance, right? And case Muratori measuring code, he emphasizes on performance, especially in some critical sections of the code. Okay, I also prepared a few examples with clean code and performant code, just to consider the difference. Let me share my. Yes. With Visual Studio. We have a few groups of examples. The first one is just a plain JavaScript functions. And they are solving just general tasks, JavaScript tasks with some mocked data. And they are grouped on a clean and on a performant approach. And here we could see that trying to find the average event number, right? We set a few functions according to all level of abstractions, which Bob Martin advocates to. And we also using reduce here, we're using filter here, we're using mass floor here, random, and so on. And when if we launch that code, we'll receive a time of performance is 25 milliseconds. And if we take a look on performant code here, it does not use filters, reduce, it does not set any functions for abstraction. It just uses the straight for loop. And that code, it performant in 3 and 5 milliseconds. Of course, like the estimation, it depends on computer, it's on CPU and so on, and it differs from the time when you launch the test. Although in average, the numbers they repeat, they tend to those values. And why this happens? Because when we use like JavaScript arrays methods, like filter reduce on the background, they creating like copy of our arrays, and when there are a lot of data, they creating more and more copies of huge and huge arrays. And they're going over those arrays twice every time, right? So it takes much and more and more time. And let's try and launch in one more example. First clean, right? Which will calculate the max value in an array, right? And also performant. So the difference is not so huge, although it's noticeable, right? Also noticeable. And let's launch the last one. And performant, nice. It's the same, right? This difference is not noticeable. And here we could see also on the previous example, we could see that also we have mass floor, reduce, right? And here we just have a straight array, right? I'm sorry, mass floor is for setting the setting the data set, right? The same mass floor. And on the third example, we have we also using reduce here, and on the performant way, we are using just a clear for loop. So in such small examples, we could see that for loops, they could be more performant, right? It's just a piece of approach we could use. Also, what I would like you to show is clean code and optimized code, which is using the polymorphism, encapsulation, and so on, right? Approaches and how it will perform. That clean code file it describes the shape entity, which is basically repeats the basic example of what Bob Martin said in his book, and then Case Muratori started on criticizing and trying to improve. And here we have like Kvar implementing shape, right? And it has an array array method, right? And if we launch it, and take a look how much will it take. It takes 58 seconds, and optimized code, it took 28 seconds. Let's take a look how it was implemented with optimized code. We have not used classes. We just used a type. And we have not set the specific method to all the class. We just used the switch between types, and it made the code much faster, right? Of course, like we should consider those consider pros and cons on such approaches, because that code it does faster. Although, if in real world we'll start on writing like some very in some commercial project and some real client, we start on writing such way of the code on the base entities, right? It will make harder for us to support it later, right? I think switch and case here, it may be hard in future. We should consider it. Although we should be aware of such drawbacks, that clean code, it's not like a magic that could make our life easier. When we are deciding when we decide to write how to write this function, which approach to choose, we should consider if to write clean code with abstractions, polymorphism, and single responsibility, and all the principles, or how much data we will support later, and how that abstraction could influence our code later. Yeah, so maybe let's talk about why that code was, just to summarize, why that code was slower, right? Because it why clean code in the examples was slower. it because it has extra functions code, like clean code usually splits logic into smaller functions. Each function can add a call stack overhead, especially inside the loops or chaining operation. And it also adds multiple iterations. Like I showed like filter, map, sort, that they are doing the iterations few times, and also like object cloning and spreading. When we are using spreading, it's like it also might make a copy of data, right? So we need to understand that abstraction logic is adds clarity, but it sacrifices sometimes in low-level controls that helps with the speed, like cache and reusable variables, and avoid relocation, right, of variables. And to summarize, here we have useful links, right, which leads to the conversation of case Muratori and like the initial article of criticizing case Muratori, criticizing Bob Martin, then the discussion log, and they like example their a GitHub example of a code we showed here on the presentation. Yeah, to take a look. Yeah, there is some space for some questions, and if any.
Yeah, guys, if someone has any questions, please unmute and ask, or write your question in the chat.
May I please ask the question?
Sure.
Thank you, Valentyna. It was very interesting presentation. And may I ask you, where do you stand on this? What's your personal opinion? Because like I'm not quite sure that case mandatory ensured me in the writing performant code over the clean, because in the real projects when we trying like to write clean code, we have some kind of agreements between engineers, and it really helps in the future. Otherwise, when we write code only based on performance and our current needs, and this sometime it could be like a mess, and it does not provide any boundaries for and room for agreements. So I wanted to ask you what's your opinion on this?
I may say about my practical, right? What I practically face it on, like writing like clean code, and how I face it on when it was not doing what it's supposed to do. It wasn't yeah, what I mean by it. I totally support on basic following basic principles like meaningful names, right? Abstraction where it's still useful, and so on. And I totally support like conventions inside a project that everyone following the same strategy and so on. Although it also depends on the stage of the project, right? When we are doing just a basic, some maybe minimum value product, when we are doing some POCs, there is no need to follow strictly like clean code, right? And another way, it's also not very so much required to follow like to consider performance, because we just want to see how it looks. But when we are talking the real project, and it depends on the task we are resolving. If it's the basic process of developing the standard procedure, like following the standard procedure for the already created part of the code, we just have to follow conventions, definitely, and the clean code principle and so on. But when we have to resolve some new come up with some new solution to just create issues that just appeared. For example, we have to take like 500,000 data and do something with, like split it on the batches and do something with it. On that part, and we do not do it every day, right? If we do it every day, we may come up already with some clean and performant solution. But if you are not doing it every day, and it's kind of a new approach for me, so the idea is that we should not follow just basic standards, like bluntly follow the basic standards. So in project we had standards to follow clean code, but if task your task is not common, is not what already been done, you're creating something new. You have to consider and make that balance, right? And sometimes I would say it's better to write performant code, right? To sacrifice all the conventions inside the team and so on, and write the performant code in such specific tasks, right?